Good afternoon to everybody and welcome. The time says it's 2 o'clock, 3 minutes past 2. I'll just wait 2 more minutes, then I will start. Please confirm that you can see my screen and you can hear my voice by greeting each other or just saying yes. Ashley, can you see my screen?
Yes, I can.
Okay. 1 more minute, then we will start. Sorry, I just need to find out C.H. Who is that? CH. Okay. Chance. Thank you. All right, guys, I will start by making an announcement and then we will continue just to make a few announcements. First announcement is that for this session, please mute your mic. In case you have everything, in case you have a question, then you can unmute and ask a question. And secondly, it is a good idea to always make sure, like I have names on your streams or your identification is clear. I might ask you what is your name and so forth. I also would advise some naughty students, please do not write on the screen or anything like that because it mess up recordings. We are also recording this session and we will kick you from the class and then you have to write a letter explaining why you did it and we will then see if we can admit you again. So just take note of that one. Also, you guys probably are following media, so they said that we should already start with alternative to teaching and that by August, that's where we will basically commence with the school. And some of you already know by August, then it's only 1 month left and then it's exam because oral starts normally in September. So we encourage you to study ahead, and if you have any other questions that we need to tackle, then forward questions to me and then we can now start with classes and look at those questions as well. I want to start with vectors today, and hopefully towards the end of the lesson we will see if we can go back to some of the questions we had previously, because once we explain vectors it will make a little bit more sense. Before I start, is there any question from you guys? Any questions before I start? Okay, if your mic is also not very clear, you can also always type in the chat. I will try to keep it open and see what somebody has typed. And then for those of you, if I've missed something, please remind me of a question in the chat so that I can also go back there. Last lesson, I was informed that I might be a little bit too fast. So I will try and slow down my pace as much as I possibly can. All right. Okay, let's get started with vectors. So with vectors here, you will basically understand vectors in 2 dimensions and perform calculations involving vectors. And firstly, we will look at a definition, and then we will try to explain the definition in more detail later on as well. So a vector is a quantity that has both magnitude and direction, okay? So there's 2 things attached to it, magnitude and direction. Another person can say a vector is a quantity with a size and a direction. So size and magnitude is the same thing. And then direction is just direction. Sometimes we see in other definitions that it has a length and a direction. So the word magnitude just refers to something that we can basically calculate. Then the direction is basically in which way it faces, right? So this, throughout the lesson, we will always refer to this, and we will also explain them a little bit more. Then we have vector notation. How do we represent a vector, or how we write down vectors? So we have a standard notation for vectors. And here again, you can see we have this column. We call the first one over here a column vector. I hope that you can also see my mouse. So the first one over here, with the X and the Y, we call the column vector, where the X is on top and the Y at the bottom. And you will have seen that we've used this before in the transformation, where I said, okay, the X value is on the top and the Y value is at the bottom. You also have another one, which is a row vector, but for grade 11, this time we are not focusing so much on row vectors. Instead, column vectors will be used a lot. And then we have a vector notation where we represent a vector using our normal straight line that we have. All right. So I'm just trying to make it a little bit visible so that you can see that. So over here we have a normal line called AB, but on top of AB there is an arrow. All right. So that arrow, it refers to the direction. Okay. So the arrow refers to the direction, and we remember that when we define a line, we normally use capital letters to define a line. And this line that we're talking about can be in a shape. It can be from triangle ABC. It can be from a quadrilateral ABCD. Okay, it can, or ABCDE. It can be from any other thing, right? But this is just like saying that specific line AB is a vector because it has that arrow on top. And then the normal way we sometimes do is, if we don't use this form of the capitalized letter with the arrow on top, we use a small letter. Okay, so we use a small letter, and then normally the small letter is what we use as a vector, and then that is the way we do it. Other notations is we have a small letter with a small line underneath. There's other ways we also represent a vector. Then over here we have a vector A, the A that we are showing you, and A is coming from O, which is the origin, and going to stopping at point A. This is one vector called OA, and I'm now over here, all right? And then there's another one that we were talking about, the AB vector, vector AB, and you will see that it's having A and B. Napume, if you have a question, please make sure you ask it as well. All right, so I quickly want to spend a little bit of time. Also, I will explain how the arrows tell us about the vector as well. And it says here, consider the vector from the origin O to the point A. This one is the one that we have here. We call this the position vector of point A. So all vectors that start from the origin, okay? Origin, remember we said that the origin in our Cartesian plane is where X is 0, Y is 0, okay? Remember that because previous lesson about transformation, we said that normally we will go to the origin where x is 0, y is 0, right? This is the coordinate of the origin that we will always find. So all vectors that start from the origin and go either way out, we call those ones position vectors. And we could represent them in any way. This time we represented it by a small letter a. We could have also represented it in the form of OA with the arrow on top. And we could have represented it in any other different ways as we wanted to. All right. And then for AB, we say that AB is a vector which originates at A and terminates at B. And that AB is the position vector of B relative to A, but the last part is not very important for us to know. What is important for us here is how we will write down the given vector. Okay, so let's say this was C and this was D. Okay, so if this was C and this is D, so we will first start by not just writing the letters, or sometimes it's easy to write the letters, it's also fine. But sometimes you must also look at the direction of the arrow. So there's two ways. It's either you do the alphabetical order or you start with the arrow first, okay? So if your arrow is pointing in that direction, right, where the head of the arrow is, that's where the D is supposed to be, all right? If the arrow is pointing in the other direction, then the D must be first and the C must be second, all right? But normally we try to, most of the examples, the arrow will point towards the right, but it does not mean that this is the only example we have. Maybe it will be better if I just draw in another example, in this case, like this, all right? So over here we have a vector C, D, well, now it's DC, and you can see that the arrowhead is pointing at the C and not at the D, okay? So this is what I mean when we are going to represent this as a vector notation. Then we will first start with D and then go to C, and then the arrow will point at C, okay? That is now the DC that we have. Or if you start with the letter first, C, D, right? Then your arrow must now still point at C. So the arrow will go reverse side. It will go the other side to C. So that is a very important point that you should also note of when we are writing vector notation, right? Where the arrow points, that should be the last letter. And we call that one the terminal or terminated point of the vector, all right? Is it clear so far? May I proceed?
No, sir, please explain again.
Come again? I should do it one more time.
Yes, please.
Okay, so let's do it one more time, right? So the first part we are looking at is vector notation, all right? So vector notation or standard notation. Notation is just a way of how we write down a vector or represent a vector. All right. So the first one here, if I can add a text here. So for the first one here on top, this is called a column vector. Okay. So for a column vector, that is the sorry, I will remove this in a short while. It's where you will see this column and X on top, Y at the bottom. We spoke about this when we were doing the transformations, and I always went back to column vectors. We will go back to transformations again after explaining vectors a little bit more. So this is called a column vector, all right? It's a column because the way it looks like, it's, if you look at a table, you have, in a table, you will normally have rows. So this will be row 1, this will be row 2, and this will be column 1, okay? If I use a different color to represent column, so we have 1 column and 2 rows, okay? That's why we call it a column vector, because the column is the one defining this. Doesn't matter how many rows we have. We could have more, it's not limited to this, okay? It can still have Z somewhere down at the bottom, and then this will be 3 rows, but it's still 1 column. So that makes it a column vector, right? In most cases, for our vectors, we will stick to 2 by 2. And when we go into, not 2 by 2, I mean 2 by 1, if we go into more details, then it will become matrices, but that is on another topic that we have, okay? So this is called a column vector. Then the other way of representing a vector is by using the line itself. If you have a line like the one over here, I'm looking at this line here. This is a line that we have. It's called a B, all right? So the line has an arrow pointing at B. And because that line has an arrow, it becomes a vector, and we represent it as A, B, which is the letters, and the arrow of the vector on top, where the head, that is now the pointing part of the arrow, is pointing at B, okay? So that is how we represent a vector if we have a given line, all right? In which cases, it will mostly be what you receive. And I also explained by a line, this line AB can come from many different places. It can come from a triangle. Maybe this was a triangle called ABC. If you see here at the bottom, it could have been a triangle, but we said, okay, just focus on the vector AB. It could have been a quadrilateral. It could have been a rhombus or a square or a parallelogram. It doesn't matter. But here we are saying focus only on AB. So it doesn't matter what shape it is, as long as you can identify that I see A, I see B, there's an arrow, that is a vector, okay? And that is how we would have represented it if it was only lines. And then we said another way we can represent a vector is by using small letters or lowercase letters to describe them. Okay, so if it's different vectors, each one will have a different lowercase letter. And then the questions will revolve around that lowercase letter. So in this case here, we have an A over here. Let me just use another color. We have an A over here, and that A is this vector that is represented now here, all right? So instead of saying OA, we are now just saying, okay, just call it a small letter A. That is the vector that we have for this line over here, okay? And this is another way of also representing a vector, but we normally do not see this most of the time. The most common ones we see is the column vector and the line described as a vector, and then the small letter as a vector, all right? But somewhere in the questions, we will always tell you it's A is a vector or vector A or something like that. All right, and then I went into explaining that we have, let me just remove that. See, we have what we call a position vector, which is this over here. A position vector is a vector that is starting at the coordinates of the Cartesian plane, 0 for X value, 0 for Y value. So when the line starts at the center, all right, of the Cartesian plane, and it goes out, whichever direction it goes out. It doesn't only need to be that direction. It can also be in that direction. Doesn't matter. As long as it starts from the center, we call this a position vector. Okay. So when the question refers to a position vector, then you will go to the center of the Cartesian plane, and where X is 0, Y is 0, and then you will see, okay, that's the vector that we have. For those who are here, this new vector that we just drew, we can call it a small letter B. Okay, my B looks like a B. Can be small letter B. Since that one is A, this one is B. Doesn't matter. Okay, as long as they are different. And we also explained how we are going to represent this letter. So in case this was O and this is a C, okay, OC. And we say you want to write down now the name of the vector, but the B was not there, okay? And we say, okay, represent this line as a vector, or write it in vector notation. Then you have to follow certain rules. So for example, here you see that in this case, we did AB, okay? Because some of us, we learn in algebra, we always do alphabetical order. However, with vectors, it does not need to be alphabetical order, all right? As long as your description of it is correct. So in this case, we have O and C. So I said you have two ways to represent it. It's either you start with the arrow. So if you start with the arrow pointing in that direction, okay, then you must notice that the head of this arrow must be the same letter at the head of the diagram representation. So at the head, I must have a C, and then at the tail, we call this the head. Let me just write it down here. This is the head. Okay, this is words that we will use a lot in the class, and this is the tail, all right? And this is referring to the arrow, all right? The head of the arrow, the tail of the arrow. So then the tail will be first. And this is based on the arrow, okay? And if you do not go this way and you want to write it alphabetical order, so you start with C and you go with O, because this is normally what we do in algebra, you write everything alphabetical order. Then your head and your tail must still be the same when you put the arrow. So the head is the C and the tail is the O. So my arrow must go in that direction. Okay, so it cannot now go in the other direction because O is not the head, C is the head. All right, so that is the different ways we can represent the vector. That is what I've explained in the first lesson and repeated it again. All right, so I hope it is clear now. All right, for those who are just joining us now, we are recording this session. I will make sure to upload, especially the first lesson, so that you can review it again. All right, may I proceed now? Etnapume, I hope it was clear. And
Yes, sir, you can proceed.
okay, so let me just clear the drawings. So the next thing we will be looking at, I will be going to the next slide, is some of the key terms that we will try to go through today. Maybe a lesson will not, one lesson will not be enough. So normally it takes about 2 lessons. So we have a vector we already defined. We have magnitude of a vector multiplication by scalar, vector addition, vector subtraction. Okay, there is vector representation as well, but that is normally on the diagrams and how we will be representing the vectors. Okay, sorry about that. I just clicked off. So in terms of a magnitude of a vector, we will talk about that in detail in the next presentation that I will have, and we will spend a lot of time on that one. Okay, so let's just continue over here and keep in mind the key terms that we will be focusing on. All right, so let's quickly talk about magnitudes. Quantities which only have magnitudes, okay? Magnitudes, it means it only has sizes or length of things, are called scalar quantities, okay? A scalar, all right? So there are now 2 mathematical quantities that we have. We have a scalar and then we have a vector. These are the 2 quantities in mathematics that you will find. One will always be a scalar, the other one will be a vector, okay? And these quantities are independent. They are found through everything. In finance, you will find vectors, right? When stock goes up, then up is an arrow going up, and then you will have an amount there. How much did stock go up, or a percentage? How much did stock go up? Or if the stock falls, then you will have an arrow going down, and you will have an amount of assigned to that arrow as well. So I'm just putting in accounting as well because my class is accounting orientated, but you will find it everywhere. Okay, so it's not just strictly to mathematics; it's everywhere. All right. in our cases, it will also be covert cases and so forth. So arrows going up, arrows going down, and all those things, right? So scalar quantities that you already may have worked with is time, okay? So an example of a scalar quantity is time. Another example is area, distance, how far, okay? 2 meters, 3 meters, 20 centimeters, that's also a scalar quantity, right? Then we have a short example here. Will a ship sailing 8 kilometers on a bearing of 0.75 degrees get to the same place as one sailing 8 kilometers on a bearing of 165 degrees? So this is just a question referring to bearing, and we believe that you guys have done bearing before. So it's like, oh, come back to bearing. And this could have been a similar question in the exam. Where we just put a ship there and we tell you, oh, you're sailing in that direction, and the other one is sailing in this direction. Will they get to the same place? That is the question that we are asking. And is there anybody who will give us the answer for this simple question? The floor is open to unmute your mic. Maybe I should ask names now. Maybe we can have Bewita. What is the answer to this question? Or Napume wants to answer, but you mute your mic. Just unmute your mic and then you can answer the question. Question is this one over here, right? Will a ship sailing at 8 kilometers on a bearing of 0.075 degrees get to the same place as one sailing 8 kilometers on a bearing of 165 degrees? Question mark. Will they get to the same place? I think it's just a yes or no answer. Any takers? Bewida?
Yes, sir.
Are you giving the answer or are you just saying yes? Napume?
I am answer, sir.
Okay, if this ship is going this way, right? There are, let's say, 2 ships, right? All right, I think you cannot see the other one. The other one is behind, and then there's one in front. Okay, so one is going in this direction and the other one is going in that direction. All right, will they get to the same place?
Oh, no, sir, they will not.
Okay, so the answer here is no, they will not, right? Because this one is going to Keetmanshoop, that one is going to Grootfontein, right? So sometimes we replace the same question, we just put Grootfontein, Keetmanshoop there at the bottom, and then we ask you some of the same things in the exam, right? So that is basically what we have, right? So let's proceed from this example. Right. And this is the next example that we have. Will an aeroplane going at 750 kilometers an hour north get to the same place as one going 750 kilometers an hour east? I think this one is still also no, because it's again same different directions. Okay, although the speed is the same. Okay. So what we wanted you to see here is basically try to introduce vectors in real life as well, and also show you that just because a magnitude is the same does not mean that our end result will be the same as well. Okay, because here we have a different direction in which these objects are traveling at, and those 2 different directions is what causes the thing to be different as well, right? Now, a lot of us underestimate this in life, especially youngsters with Golf GTIs, all right? So if you have a Golf GTI and you are traveling so very fast in that direction, and there comes another object which is not in that direction that you are traveling in, and you are hitting it, the results are very different. Okay, so this is important. If you are driving a very fast car, you need to know the mathematics behind it, and also vector quantities and scalar quantities. And some of you are not driving, but you are sitting next to the person driving, and you should also be able to tell them, the mathematics is not working out at this speed, please slow down. All right, those are just safety precautions. All right, so in a nutshell, when we are talking about objects or quantities which have both magnitude and direction, okay, we call those vector quantities. And in this case, we had objects here, one aeroplane this side, one aeroplane that side, and we had two ships in this case also in different directions that we have. In most cases, we try to always indicate a north. If the north is not indicated, we will replace the north with our y-axis, okay? And that is normally what we will do regarding definitions of the plane for the area that we have. So the displacement of this is now just talking about the ship, all right? The displacement of the ship from P and Q is represented by a directed line segment. This is now from P to Q, and we are looking at P over here, which is this point, and we are going to Q over here, which is that point over there, all right? And we also have a straight line, and then in the straight line, we have now an arrow, which means that is the direction that Q is in, and that is what we want to go, all right? Or that is where we want to go. So if we have to, displacement is another word that they use. So if you see the word displacement, this is now normally for learners who are having physical science and chemistry as the choice fields of studies, that we would have now talked about displacements as a vector over here, all right? So that is now what we are referring to as displacement. It's normally a physics term. So if by chance you see displacement in a mathematics paper, please do not be afraid. It's just another way of vector, all right? And we represent it as PQ. Remember, we start at P, we are going to Q, and the head of the arrow is pointing at Q. And here you can also see the head of the arrow is pointing at Q. And when it comes to the magnitude, let me just quickly explain here. This is now, in a nutshell, showing us a clear indication what we talk about magnitude. We're talking about the length of PQ, the length of the line, right? The distance. So in another sense, we can talk about the distance, we can talk about the size, and we can talk about the length. What is the distance between P and Q? And who of you still remembers that we did coordinate geometry, and we said you can find the distance of a line. What is the formula to calculate the distance of line PQ if this was on the Cartesian plane? Is there anybody to take us back to that thing? Who remembers the formula to calculating the distance of a line? Let's say we had a coordinate, okay? Let's say this was coordinate x is -2 and y is 4. Okay. And then we had another coordinate here, x is 3 and y is, in this case, let's say 7. Okay, so if we had coordinates like this, and we ask you to calculate the distance between P and Q, or the length of P and Q, who remembers how do we calculate the length?
So, that is it the square thing? What do you call it? The cube root thing?
Yes, those cube
First,
root things. Yes.
Then open bracket x 2 minus x1 close bracket squared.
Okay,
plus
so, slow down a little bit while I'm writing. First, open bracket x2 minus
x1 close bracket squared
squared
plus open bracket
open bracket,
y2
y2
minus y1
minus y1
close bracket squared.
close bracket squared.
Yeah.
Are we done here?
Yes, I think so.
And anybody else to finish the equation?
So you have to square root the whole thing.
Square root it.
Yes, that's correct.
We square this. Also.
We square root the whole thing. Okay. So this is now an important part that we are talking about. And when we are, sorry, I don't have any water to drink. When we are talking about now the magnitude of the vector, we will basically just want to size the length of the line. It's exactly the same thing as the distance between P and Q that we have already calculated. And in a nutshell, it's only going to be a simplified version of it. Okay. I will leave this for you guys to attempt at home again using these coordinates. You can just, or even just solve it in the background and then type the answer in the chat, what you think the distance will be over here between these two. If that's basically what you want to do. Now, this is from the coordinate point of view, all right? So all the steps at the bottom, you have to fill it out, right, or complete it. I'm gonna remove that formulas so that I can continue to explain what it is we are talking about here in vector notation and form. So over here, we have our normal vector, how we describe the vector. It's either PQ with the arrow on top, or they also just described it as a small letter p. In this case, we have here. And when we are looking at magnitude, we put in this extra lines over here, this one and that one for the vector, and this one and that one. All right. Is there somebody, I spoke about this in my classes. We told you what does this two lines mean. Is there anybody who remembers what it means?
Mm-hmm. I think so. What did you say, Auntie?
Hello, I can hear your auntie talking. You must always mute your mic. Okay, guys, we have about less than a minute left. So when you are reconnecting, we are going to stop this session quickly. Quickly reconnect again to join, and then we will be having I think it's the next 45 minutes left, so that we can continue. So think about what do we call those